Hello, boys. I, Dr. Pradeep Kumar Srivastava, welcoming to all of you in my class. This is the subject name is Water Resources Engineering, and topic is the bed load, suspended load, and total equation. First, we will discuss, my dear boy, what is bed load. Next, suspended load, and again total equation. My dear boy, in your life, how many rivers you have seen, especially which time when the river is dry and when the river is running with full of chamber. So when river is running full of chamber, they have high current, and condition it is due to current. The water has not control to the corner, bank corner, and they have cut the corner to expansion for him. Why he cut? Because he want to expansion. He want to reduce the velocity. He want to reduce the velocity. And in this condition, my dear boy, corner has been cut. The river width is increased. So slightly velocity has been down. The connection is like that. Suppose this is the graph, and in the full of chamber, when see this diagram, if the water, this is the, dear boy, this is the normal chamber of river, and this is the banks. But when it flow up to this condition, so graph should be increased like this. Like this. And if this current of water has been released due to cut of bank condition, due to the cut of bank, it means its position has changed like this. So this is the speed of this. And if the bank made of this, so velocity current of this. So you have seen the entire all the situation had depend upon your current of water, velocity of water. So how velocity generate? If now how velocity generate if the sudden rainfall has come and the high intensity. So entire all the area of water come in this all area come in this chamber. And now this air is not here. Now here is not the river bank. Here is what it? Here is the irrigation field. So dear boy, with rain, the alluvial soil has come in the river, and condition of this river bed is made like this. You can see in this graph also. And this, it is a graph. Suppose it is the 1 minute. The bed graph is existing like this, but due to bed load and which alluvial has come from the irrigation field, which alluvial come from the farmer's field. So development like this. So what is this? Is alluvial or fine sand, and this is the bed load. What happened? My dear boy, in this case, this chamber of the, this is the chamber of the river, has full by alluvial soil or sand, fine sand. So where water will be go? So water will be make another rasta, another way. It will make another way, and it will be go up entire the villagers area or urban area. It will be spread. It will be not follow the rule of river. It will be not follow the rule of river. It will, my dear boy, uncontrolled flow. It is called uncontrolled flow. So what we say that? We say, oh, it is flood. This is the reality of flood. So let us start bed load, suspended load, and total equation. The term bed load or bed load describe particle in following fluid, usually water, and that are transported along the stream bed. And bed load is complementary to suspended load and wash load. bedload move by rolling, sliding, and salt and salting, hopping. Generally, bed load downstream will be smaller and more rounded than the bed load. So, upstream, a process known as the downstream fining, this is due in part to attrition and abrasion, which result from the stone and cooling with each other and against the river channel. So thus removing the rough texture, rounding and reducing the size of the particles. However, selective transport of sediment and also play a role in relation in downstream finding smaller than the average particle are more easily enter and turn than longer than average particles, since the shear stress required to certain a grain linearly proportional to the diameter of a grain. However, the degree of size selectivity is restricted by the hiding and effect described by Parker and Klingeman 1982, where in larger practical protrude from the bed, whereas small particles are shielded and hidden by larger particles, with the result that nearly all grain size and become interned at nearly the same shear stress. Okay, clear? Now, the suspended load of a flow of fluid, such as a river, in the portion of sediment uplifted by the fluid, if the portion of sediment uplifted by the fluid flow in the process of sediment transportation, it is kept suspended by the fluid turbulence. The suspended load generally consists of the smaller particles and like clay, silt, and fine sand. The proper purpose, a method for the establishing both the velocity profile and concentration profile for suspended sediment based on measured data consisting of the average velocity and average suspended sediment. Concentration in the river and irrigation channel. In addition, a numerical model For computing suspended load and bed load, who also developed for computing bed load and transport rate when measurable load is available. In this study, bed load for the published laboratory and field sediment data were computed using the presently developed numerical model based on 4 different bed layer and thickness. They computed bed load were found to be reasonable agreement with the values from Einstein's bed level function when the thickness of the bed layer was taken at 100 tan theta d or 0.05 d. The numerical model developed in this study may be used to evaluate the validate of other bed formulas. Now sediment transport. We will read how sediment transport. Are you understanding how sediment is available here and how they transport it? That is the channel there. So we will read about the sediment transport. In any particular matter that can be transported by fluid flow and which eventually is deposited as a layer or salt particular on the bed or bottom of the body of water, other liquid. The generic category of the sediment as gravel, sand, silt, and clay. Gravel, sand, silt, and clay. So, content, properties of water and sediment, incipient, motion, criteria and application, resistance to flow and bed from and bed load transport, so suspended load transport and total load transport. So first we will discuss properties of water and sediment. Water and sediment. Dear boy, now you have understand how sand come in the river. Any doubt? You can ask me. Property of water and sediment. Introduction. The surface of sediment transport deal with the internal shift between flowing water and sediment particles, and therefore understanding of the physical properties of water and sediment is essential of our study of sediment transport. So what is the terminology? What is the terminology? Actually, density mass per unit volume, weight per unit volume. So Y is equal to Pg, formula will be applied. A specific gravity. It is the ratio of specific gravity. It is the ratio of specific weight of given material to the specific weight of water at 4 degrees centigrade or 32 degree Fahrenheit. And if the average specific gravity of the sediment in 2.65, nominal planimeter, nominal diameter. So it had diameter of sphere having some volume as this paradigm, and the sleeve diameter is the diameter of the sphere equal the length of side it through which parallel. And now, my dear boy, this is a terminology. So fall diameter, it is the diameter of a sphere that has specific gravity of 2.65 and has the same terminal fall velocity as the particle when the such of followed to be determined for the water tempered of 24 degree per second, and wall velocity. It the average terminology setting velocity of parallel lining line alone in the consequent utilized water of the finite extent, and when the fall velocity is the measure of the 24 degrees centigrade, it is called standard fall velocity. Now, angle of purpose, sorry, angle of repose. So it is the angle of slope formed by a given material under the condition of principal building. This is the terminology. It is the degree to which fluid just flow under the applied force, dynamic viscosity, and they consist of cooperation in letting the shear stress and the velocity gradient. The property of water, the basic property of water that is important to study of the sediment importance and minimize the following table. Now, property of single sediment particles. What is single sediment particle? Actually, dear boy, this is all depend upon the size of element. Fine sand, coarse sand, have you listened this name? But in this condition, the value of sand, let's find out, or after that we will calculate. Now, property of a single sediment particle. So size is the most basic and readily measurement property of the sediment size has been successfully. So describe the physical of many reaction purpose, the size of particle can be terminated by host size. Shape. Shape offered to the open configuration of a participate regarding its size of the composition and a core shape factor is the commonly used to the describe in the shape. Now density. The density of sediment particular a reference to mineral composition, usually especially gravity, water-borne sediment and particles are formally composed of water and good with a specific gravity of 2.65. Now fall velocity. The fall velocity of sediment, particular in the quiescent column of water, is directly recharged. Recharge. The fall of velocity sediment particle in the consequent column of water are directly related to relative flow condition and between sediment earliest and power during condition of the sediment and entrainment, transportation and disposition. So it fail. It is effect to integrated result of size and shape, surface, roughness, specific gravity and viscosity is found. Full velocity can be solved from the the two equations. What is the full velocity? Just you have seen. If this is your full velocity, this is your full velocity. Okay. Now, theoretical consideration of track certificate. For a very slow and state by removing shear in the infinitive liquid, a very small Reynolds number of the drag coefficient can be expressed as by this formula. By this formula. Now we will discuss particle size distribution. How suspended load will be developed in the river trough. And now which site it will be found at. So dear boy, if camphor, if chamber of the river is small and flood water has come from the farmer's field, so it particular will be very, very small. Okay. So while the properties and behavior of individual sediment particular of fundamental concern and the greatest interest in progress of sediment. So various sediment particle moving at my time may have different size, shape, specific gravity, and send the matter. Okay. Now the two method of the company size frequency distribution curve. The simple detail in the percentage, the sample computing in the interval, so it uploaded to the friction. Now percentage time can be lecture, and it is the frequency histogram currently available. This is the property of sediment. This is, and this is the position of when it will be evolves. Now bulk properties of the sediment. Sediment mixture. It is important in the determination of the volume of sediment. Deposition of it always important in the diversion from d from diameter, volume, or sediment weighted and vice areas. What is second, my dear boy? Incipient motion criteria and application. Incipient motion. Due to independent motion is important in the study of the sediment transport channel and degradation and even of due to sophisticated random and nature of the sediment movement along and alluvial bed, it is difficult to define precisely at what flow condition of the sediment particular will be begin to move consecutively, and it depends more or less. No intercipient motion criteria. What is? Most intercipient criteria are derived from the either a shear stress, a velocity approach, or probability approaches, or other certain. Shear stress approach. Water's animal this is the article shear stress is proportional to the sediment diameter. So applied the dimension analysis for the determine some dam, the time factor that important in the determination of the equipment motion in the shear stress. Now velocity approach. Frontier and SOBI 1926 made a maximum permissible values of the mineral and permissible valuable by canal of although there are theoretical study is super table and they the result are best of the input from and should be usable the publicity and other design. Now Houston and ASCA study, this is also for shield. Yeah, what is the shield position? Actually, the shield deposit at the rolling to rolling and it will be transferred to also. So this is the form of visual storm and AISC study. Now Houston and AIS study. This study is the Houston study. Sediment size and sediment layer and channel slope and constant. These are all calculation for the sediment point. These are now resistance to flow the bed form. What is this resistance to flow the bed form? Dear boy, if a river chamber have some sediment load and when water will flow on that, so that will be forces in against type, and this is the region of percolation and other transportation and other ways to concern in a window. Now introduction. In the study of open channel, hydraulics with the weak boundary, the roughness coefficient can be treated as concentrate after at other writers. Wonderful. In flammable hydraulics, the boundary is removable and the mistakes are to do on time. In fluoral hydraulic, the boundary is mobile and the resistance to flow, the roughness coefficient is variable and resist formula cannot be applied directly. Without knowledge of how the resistance coefficient will be changed under the different flow and sedimentation condition, extensive study has opened made by the different type of investigations. One, the basics of the vestiges offer after from the which other leveling and tactic regarding and hyperability of the accuracy of the result. This is the formula for rolling standard bed load. Now, bed load form. Here is a strong interrelationship between resistance flow and bed configuration and rate of sedimentary transport. In order to understand the variation of resistance to flow under the different flow and sediment conditions. So it is necessary to know the definition and the condition under which different bed form. Now, for moving length the same under as the channel with the greater and height comfortable to the mean depth of the genetic flow, and these are point bar, aliens bar, heighted to bears, the tributary bars, and shown in this picture. See this picture. Okay. Now dunes. A matter of what is dunes? Actually, in the riverbed, so many small oversight step has been developed, and this is called dunes. So dune bed form are smaller than shear but larger than reply. They are formalized out of the face with water surface profile. Now transition. The transition bed configuration is generated by flow condition intermediate between those preceding dunes, and while a plane would cover to remaining. Now introduce. These also are called standing webs. This is webs. This is webs. And the bed and the water surface profile are in phase. So while the flow is moving in the downstream direction, the sand wave and water surface wave are accurately moving the upstream of direction. Now, shifts and poles, so these occur at the relatively large slope with the high velocity and the sediment competition. Okay, now transition. The transition bed configuration is generated by the flow condition. If current is high, it is speedily flow. The transition bed configuration is generated by the flow condition intermediate between those producing dune and plain bed. In many cases, part of the bed is covered with dune, and while a plain bed cover the remaining. Anti-dune shortage. These are also called standing waves. The bed and water surface profile are in phase, and while the flow is moving in the downstream direction, the sand wave and water surface wave are actually moving in the upstream of direction. So highly velocity and sediment concentration. This is the bed form. In figure, you can see that this is the bed form. Now, flow regime. The flow in the sand bed. The flow in the sand bed channel can be classified as lower and upper. So, lower upper flow regime with the transaction in between, the bed form associated with this low regime are followed. So lower low regime, so ripples and owns, and transition zone, bed congregation and range from the tune, and no plan need to the attitude. So upper flow regime. So plane with the sediment movement and amid dunes and braking condition, attitudes and standing waves. Now factor affected the bed form. First depth, next slope, again density, fourth stage of bed material, and gradually of graduation by material, fall velocity, channel cross-sectional map, and seepage flow. And seepage flow. So this is the resisting to flow with the mobile boundary. So my dear boy, what is the mobile boundary? Any have knowledge? Dear boy, a condition on which time rain intensity is high and chamber of the river has been filled up to upper level. So work of the river is to move, and if boundary is not rigid, then it will be moved with the corners. Green roughness on skin roughness, that is directly related to green size, and form roughness, that due to the extent of the bed form at the change with the change of bed form. The morning roughness coefficient is used the total coefficient and can be expressed as N equal to N for M. Now the value of H and is the reporting to the sediment diameter to the value of N proportional to the sediment planimeter and the diameter to the sixth power. However, there is no reliable method for the computation of N. So our intensity to determine the predict variation of our the roughness, cost and measure problem. This is the resistance raw with the mobile boundary and the surface drag and the form drag. This is the formula. Now bed load transport. How bed load transport? When the flow condition satisfied of the exceed the criteria for incipient motion and sediment particles along the alluvial bed will start move. In the motion of sediment, as calling, silting, or jumping alone, the bed is called bed transport. Generally, the bed load transport of a river about 5 to 25%. That is the suspension. However, the coarser material higher percentage of the sediment by the transported as a load. So thereby, this is the sediment load, sediment transfer, and this is the theory formula. So on this chapter, I have prepared few MCQ, and I am interested to ask you how much you have learned from this my lecture. So I will ask you, so you be ready. A multi-purpose reservoir is the one which. So what is the correct answer? There is 4 answers in your answer screen, and which is correct? Can you tell me? Answer B is correct. Answer B is the plant and distribute to save the various purpose. Next, manage a rain gauge should be preferable by fixed. So this is 4 answer, and which is correct? Correct answer is C, in a closed space. And a repelling line is aligned with. Correct answer is A. Now, a hydroelectric scheme operating under a head of 80 meter will be classified as So what is then correct answer? Correct answer is C. High bed scheme. And yeah, hydrograph is the graphical representation of. Correct answer, tell me. Tell me, answer is correct answer is A, rainfall intensity and time. And next question, a land is known as a waterlogged. Then, which is correct answer? C, capillary stream reaches to the root zone of the plant. Next question, 70% index of the wetness means it means a rain deficiency of 30%. Correct answer is B. Now a current meter is used to measure where velocity of flow of water. Correct answer is A. And a deep well is always deeper than a slow well, then has more discharge than a shallow well. Correct answer is B. And in last, a divide wall is provided. What provided? Correct answer is A, at the right angle of the axis of shear. So thank you very much for joining my class. You all are welcome in my next class.